Hello friends. So in the last video, we looked at Rasa's brief history of 2016 and how the founders envisage Rasa is going to be a bit of the background of the dialogue system research going on back then in 2016, and how Rasa favors like a simple but effective approach to building chatbots. So in 2017, Alan, one of the co-founders, published another blog post saying a new approach to conversational software. So you mentioned some of the points that are relevant to 2016 as well, in terms of how state machines are a bunch of if-else statements, not scalable, and talk about how in reinforcement learning, we need to define state actions and reward, where if we approach dialogue system using reinforcement learning, it will be hard to do so because we need a lot of different data. So it's, for example, it's different to AlphaGo reinforcement learning, where the machine can train against itself for millions of times, whereas in a human kind of conversation, it's hard to have millions of conversations to be trained on. And we also talked about how humans' evaluations are not reliable, and the reward is towards the end of the conversation, which means it's going to be difficult to train. So later in the year, Rasa released this paper called Open Source Language Understanding and Dialogue Management, in which it talks about the different components of how Rasa is made, and the different techniques that is used in Rasa Core and Rasa NLU. So from the very start, Rasa has been building its framework in a very modular way. Each part can be substituted with, for example, different dataset, classifier, or word embeddings. So if we look at the architecture here, we've got a message in, and then the interpreter will be, for example, the Rasa natural language understanding. It will be classifying the intents and the entities. And in terms of how they go about doing text classification, is they use the fast text approach. And in the paper Back of Tricks, for efficient text classification, the authors mentioned them training their sentence back of words plus a linear classifier like the SVM, and they managed to achieve on par results to how unsupervised learning go about training, for example, the GLOVE. So in that paper, the technique used is we tokenize the sentence into back of words, and then we represent them to be a pool of word vectors and train them on a linear classifier like XVM. And the result is much quicker training time and on par accuracy. But the author did mention that using unsupervised learning, like in GLOVE, to train the word vectors, the result has got much richer word representation power. So going back to Rasa's architecture, so we've got a message in, for example, I want a margarita pizza, and then the interpreter outputs the intent and the entities, which goes into a tracker which tracks the state, and the policy decides on what actions to take next and outputs the action, which feeds back in the tracker on the state and or have a message back to the users. So if we think about it from the first glance, this didn't seem too much different from the state machine, where we've got a state, and then we have got a bunch of if-else statement tracking and spitting out whatever actions accordingly. But what's really clever, or what's really interesting about Rasa's approach, is that instead of outputting like a hard-coded 100% certain answer in an if-else scenarios, Rasa outputs a probability of an action. So how they do that is they do it by concatenating different vector representation of the last action, the intent and the entities outputs from the interpreter, and also the slot. So what the slot means is, for example, here we've got a chat history of someone trying to book a table, and then the slot will be cuisines, people, price, and location. And once the user has hit what cuisine they want, this slot will be filled in, and subsequently changing the state of the tracker. And as you can imagine, now that the cuisine slot is filled up, then there will be a higher probability that the chatbot is going to ask a question related to people, price, and location. In addition to that, the paper also mentioned this machine teaching, where users can, as we have the dialogue, can tell the model whether the responses are correct, or is it what we expected or not. And subsequently, the model can be partially trained on the fly. So overall, I really enjoyed reading this paper because it shows how Rasa's approach to dialogue system is they combine both NLP research, the engineering approach in terms of modularity, thinking about how do we maintain the models, and how do we scale to different users, as well as the business side where we keep things as simple as possible but effective. So yeah, if you're interested, please feel free to check out this paper.